These are the hookups now?
Yeah, we're getting there. First thing you do, you connect the green wire from the ground of the test board to ground green wire of the K board, to be tested board. And you take a red clip lead from the red wire of the K board to the hot lead of the test system, test board. Then you take a brown wire from the brown clip lead from the brown wire of this harness to the hot lead also. What it does, I should show you this, we should look at the circuit when we're doing this. Circuit here is on this board. This is the circuit of a K board. Now, the way this turns on is you have, well, first of all, you have battery power to a transistor. This has to be correct. It's turned on by a voltage signal from the computer. The computer pulls up this base on this transistor, which makes this conductive and makes this transistor conductive. Right, so it basically fakes the input from the computer. You just pull this point up, right, which makes this transistor conductive and pulls this bias up and it makes that conductive. So we hook up the brown wire from the hot of the test fixture to the brown wire of the harness. Okay, now we clip the meter. First we do this, we put on the red white wire, which is 5 volts. That's the 5 volts that is generated here by this IC. In the picture it's this IC, L4805 in this case. This is just simply a low drop regulator. This here is this transistor. Turns the whole system on. Alright, so then the first thing is that we want to see the 5 volt coming out of the regulator. Alright, so this is this wire, the white and red here. So to turn on the power here, something is wrong. Oh, wait a minute. It doesn't work if you don't ground the meter. Okay, the meter of course has to be grounded. Okay, it's 506, close to 5. Okay, now if I will take this wire off, you see it goes to 0. That means if we will take this voltage down to ground and let it float, it will turn off the system. And I'll pull this high, and this, by the way, is something like 8 volts. It could be 5 volt is fine too. We don't have an extra 5 volt source, so the 8 is fine. It turns on this transistor and gets the 5 volt energized. Now the 5 volt here also goes to a DC to DC converter here, and it generates plus or minus 15 volts nominally. Okay, so now let's take a look at that. Here would be, at this point would be plus 15. Okay, it's a little more. And the next one over, I will shut this thing off in between because I don't want these things you see to get, these regulators to get too hot. The next pin here is minus 15 nominally. What's going on here? That may be a problem. Let's see. Oh, there it is. No, it's just pressure of contact. This is mine 1475 now. This is the
common of your DC to DC converter is common of the still common of the system.
Right, right. This is the common. This is the ground. You see this? This is the common. common here, 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 and you know all of these leads are grounded to the same common ground. Incidentally, it's not exactly. It's a little more than 15 volts, a little less than minus 15. This has to do with this chip, with this thing. This is. I'm sorry. I'll take it back. No, it has to do with. When they're loaded down a little bit, you know, they're not exact. I mean, it's good enough for what we're doing. This plus or minus 15 volt drives the analog electronics, and as you know, that's not critical exactly to having the right voltage. Now, okay, we have this. Make the first entry here. See, we have to. The date is not anymore correct. The date is today is the 16th, right? So make a 6 out of this one. All right. The first thing we do is VDD is this 5 voltage, the 5 volts that we had. Okay. That was 5.06. All right. All right. The next test is a light test. Okay, and first we do let's block this thing here. This right now. Oh, by the way, I should have done the 5 volt test with the lead connector. Right. Yeah, you know what? There's something wrong with this.
You want 9 volts?
Yeah. Just to make sure that we have.
Ready to power?
Yeah, just to make sure that the 9 volts are there.
Okay, here I go.
Yeah. Okay, good. Okay. All right, let me see whether this works now. Yeah, that's it. These things are on occasion a little marginal, so this is okay. It's okay. Fine.
So you're powering it externally now?
Powering externally
From
because this, as I said, these things these things don't come out exactly the same. So sometimes it takes a little more power out of the 5 volt to pulls this down. We got to do something about that. But you build your own eventually, and we'll beef up the regulator. That's all it means. It needs a far more powerful regulator. Okay, we have that now. So okay, we can shut that off. Yeah, I'm talking about the power there.
Oh.
Yeah. Okay. I always like to do that because I don't trust the. Okay, we got minus and plus voltage. We got that. Oh. Black tape if we okay now. Okay, this is now we're going to establish the okay. We connected this amplifier board to the preamplifier. It's the same preamplifier that we have on there that we used, you know, in the back of the unit. Okay, so that's just the preamplifier that takes the detector signal out. Now
which part did you block?
We just blocked the entrance. There's a detector in here,
Mhm.
and we just blocked this. And here I'm blocking. This is the reference detector. We're blocking that one. So, okay, the reference detector is here. I blocked that one. I just don't want it saturated. You know, I don't want to. There's no need to do that. Let's then switch this light off. And now we're gonna. What we do now? The first thing we do. Well, not the first, but one of the things we do. This red. We go and test the. This is the white blue light wire in the harness. Okay, white blue. White blue is is 25 V00. Okay? V00 is a DC signal. See, this is the preamplifier here. And the first is the detector. Out comes a DC signal, which goes over here into this amplifier times 5. And then here another times 5, and out comes 25. See? You've got any questions? Understand what it is? You know what? This drawing on pin 9.
That's the AC signal.
Sorry, that's the DC signal from the detector. The detector signal is called V00. Okay. The DC detector signal is called V00, and it goes in here and is a non-inverting amplifier multiplied by a factor of 5. Then comes a offset, a null offset, because we noticed that there's somewhere along the line on this board there is some sort of an offset. I don't know what it is. It could be AC coupling that is rectified. It could come from this thing. I don't know. We hunted for it, couldn't find it. We just simply put a corrector in. That's all. We simply put an offset in. You see what's going on here? This has a plus 15 volts add on here. In other words, it just adds to the signal enough to make it 0 when there is no optical input. So right now I'm blocking the optical input into the preamplifier. There should be no, and we check that in a minute to see that there's no voltage coming into the system. All right. And we do that in a minute. And then at 25 times it also has no output. Okay, now let me here.
You attach to the...
I want you to get the power. That's just the output of the operational amp of the preamp. Okay, now if you turn this on up there to 9 volts, you see a little bit. Now let's shut off that light and see. Shows 26. Now here, watch out. Make sure this is not. Yeah, let's shut that light on again, huh?
It can easily be induced from that ground reference.
That's right.
Meter.
That's right. The meter. You got to get the meter onto the ground here. Yeah. Can we push that power off over there? Thank you. First time around, this is good since I have to remember myself how to.
Who's doing this before?
My assistant. All right, let me put it here on. Okay. No, let's see. It's there even if there is nothing on. See that here when the voltage is off. How do we explain that? Oh, wait a minute. Wait. This is not connected. Oh, it is. I connect this here. Let me connect it over to this wire. It should be just feeding through. See, this wire here feeds right through. Okay, the output from the preamplifier goes. There's a connection to the preamplifier. It says really from the preamplifier, but it shorts to this point. So why do we have 25 volts here? All right, let's just take this thing directly. 25 millivolts. Let's take it directly here and see what happens. And then there's nothing. Where do we lose the... In other words, now I'm putting ground here, and I put it on the purple wire on this harness. Okay, so it is 0. Now, let's turn the power on up there, see what happens. Still 0, right? Let's just see what happens when I do this. All right, there's a signal. All right, so the amplifier is working.
Meter common goes to green.
Meter common goes to green on the harness, and meter hot goes to the purple wire on the harness. This is this point. Meter on the, we have the power still on. We put the meter on the next lead, the blue, white blue. Blue wire, white blue. Now, I need a thing to turn this.
Light blue.
This light has no real influence here, so let's see what happens. Now this pot here, which on this thing here is this pot here. See this here? It has a number. But I'll have to get that to you what the number is.
First, so you have to write down first.
No, I have it on a different drawing. All right, look, we'll get to the number of the pot. See here, as I'm adjusting it to 0. See?
Okay.
There's no light on though.
Where's the light?
I'm not recording. Push this red button here. Now it's recording.
Okay. Where's the light?
It doesn't see anything.
I don't know how to turn the light on.
Up in the front, maybe? Here? That's a microphone.
There.
Yeah.
Can't take notes while I'm recording.
No, well,
No.
I'm not doing it.
No.
I'm waiting until you got the light on.
Oh, okay, then.
And I just want to see whether it has any influence on.
Nothing. So it's on. Okay.
So this light can be on. So does that help you at all? That light?
Doesn't matter.
Okay, I just try to adjust it to 0.
Okay, the port number 1 on the left hand side.
It's sort of tricky, you know. You gotta get it.
But it's very steady.
It's pretty steady.
Steady.
Yeah.
Is there any drift?
Not really much. I put it that way. In the scheme of things, it doesn't make a damn difference because when you have weak signals, you're way down on the exponential curve, and you have like a factor of 20 in forgiveness. In other words, if you're off by 20%, that's 1% error in the Kelvin temperature. So we'll leave it like that. Okay, so we said that's the first entry here. Supposedly this is dark. Okay. And we said we put in 0.000, okay, close to it. So first thing we do is we test this thing with dark, the detector in the dark, okay? Now comes the next thing. We have a thing here with a small hole, a little aperture. You know what? Let's shut that off. The battery operated. And the regulator here is never on for any longer time than a half second. So when we have this on and test it, I see normally the switch is here. I mean, it's up there. We have, we'll fix this to be more a little more powerful, but you don't want this on too much because see, it's getting hot already here. You don't want to do that. All right. In fact, I use this here to heat sink it a little. No. Now there's a little pinhole here. Now we need this good lamp here. What I'm doing now is I put the meter on 25 again. Well, now it is on 25, right? So now the next thing we do is 25 with light, okay? And what we do is we set that to 10 volts. We have to. It's on. Yeah, switch it on. Okay. All right. Now I have to maneuver to get 10 volts. All right. The way I do this is I move this whole affair. Oops. Until I get 10 volts. It doesn't have to be exactly around 10 because you see in a minute this is close. All right. So this to 10. When this is at 10, Then, and this is 25 V00, and V00 should be 0.4. All right, now let's take a look. It's close. It's 0.97. So we'll put the numbers in, 0.98.
Where did you switch the lead to, Alex? To V00?
To the purple. Back to the purple wire. Okay. I make a thing here. This is white, blue. All right. So as I set this to, well, it wasn't exactly 10. You know what?
9.9.
Makes a difference. All right. Let me go back to the 25 times to the white blue wire. All right. It's a little less than 10. The slightest little something here, it changes. All right, 10.05, okay, and then I go back to the purple wire, and it's just 0.4. All right, that's not bad. That's close enough. 10.05 and 0.400. Okay. Now, this has so far all been very easy. Now come the next thing, and let's shut that off. But what I'll do is I keep the power. What we're going to do is the ground is already connected here, and this also goes to here. There's a laser in there, okay?
Is yellow wire is the output of laser?
This is the laser. This we have to get out of the way. And we have this red one goes into here. This wire. The black one goes into the ground, which is here. And this one here is the trigger. Goes in. This is too long, but it's okay. We can use it. This goes into here. This is the trigger wire. This board is the laser power supply. Also, we have to set this right. Hook this up. This electrically fakes the laser. A bunch of resistors. Okay.
That's a load?
Pardon me?
That's a load?
Yeah, it's a load, right. Now, just get this up in the air here. Just realized something. We gotta do this first here. We gotta measure this here. Let me need another one.
Are you hooking up that one?
I'm just hooking up because this one is too big.
That here in this
Yeah, I'm hooking on this corner. Now what we do is we have a red lead here from the laser power supply. That's the power lead. That goes into this here. Right? And we have a trigger lead from here. And I'll show you in a minute how we get the trigger. And we have a ground lead going over there. Now, what I have to do, we still need this to generate trigger pulses. Alright, we can turn this on over there. Alright, good. Alright, now, alright, let's turn it off again over there. I just want to make sure this works. Okay, now, this is the trigger lead here. This really should be instrumented to make it one connection. No, won't do that. But right now, we test this power supply.
Is that on the schematic?
None on that schematic here. It's a separate schematic. I'm gonna get you that one here. We have it, but it's not on the same schematic. We have it over in the file that we copied. Over there, maybe I have to go over it. What it does is it takes battery voltage. This is the red wire. And the ground wire in this case is black. The trigger wire is white.
White.
Alright. Now,
This white wire.
over here. See this here? Now, we're measuring. Let's look, make sure I got this right. Here, this is upside down. It's like this point. Yeah, the DC point is R6. R6 is, there we go. You see, we're measuring DC output, because what this does, see, this whole circuit, it has a DC to DC converter, takes battery voltage, pumps it up to, we'll see what it is, it's between 20 and 25, depending on adjustment. We adjust this pot to vary it. Then it charges up one capacitor, alright? We can get rid of all that other stuff here. Where's my whiteout here? Capacitor, which on this drawing is over here, is this big one standing up, is being charged up to a DC voltage, right? Then, when the trigger comes in, it switches this hex FET, which in turn, this one here, well, it's a fast switch here. It switches this transistor, this switches this hex FET, which the laser is here between these 2 points, which discharges the capacitor through the laser. The laser is between one point of the capacitor and ground, and then when you, and this of course is floating because it's being charged up, but then you suddenly ground this side and the capacitor discharges, you ground it on this side and it discharges the cap through the laser into the short pulse. Alright, now